Good morning. My name is Bimalan Kalimutu. My metric number is 08DJK18F1062. This project is implement of monitoring the plants and automatically watering the plants. Objective: to detect the moisture level in the soil, to reduce human energy, and to maintain the health of the plants. Problem statement: to avoid short circuit, avoid plants dehydration. Good morning, guys. Okay, my project is smart watering system. Okay, we see about my project, function of my project, and the structure of my project. Okay, this is my project. We see the components of my project. 3 volt solar panel with attached battery to charge the power. Switch and voltage regulator to control the voltage. Arduino Uno and 12 volt SPDT relay. ESP8266 Wi-Fi module. Soil moisture sensor with its probe. And lastly, DC water pump motor 12 volt. We see the function of the project. The function of the project is very simple. When the sensor detects the dryness of the soil, the water pump start to watering the plant. But now the soil is wet, so the process of the watering is stopped. Now I can show you a demo about the process. Okay, when the sensor is detect the dryness in the soil, the water pump start to watering. When it detect the water, it automatically stop itself. This process is an automatic process. As now we see the manual process. The manual process we can operate by our smartphone. I set it the function in the app called Blink in the function as what the watering process on or off. As you can see, when we press on, the watering motor start to watering, and we press off, it's stop automatically. I'm sorry, stop manually. We also control the water pump motor by the switch. Now the switch is turned on. When we turn off, the watering process is stopped because the motor is not function. When we turn on, the motor will on and start ready for the watering process. Let's explain about the IoT of this project. Okay, as we see, we can calculate the value of the amount of the water in the soil. We can calculate as a resistance. I set it into resistance so we can easily know about the level of the water in the soil. I set it the maximum value to 1022 and the minimum value into 0. When the value of the resistance is low and below 150, the water pump is start to watering plants. When the resistance level is more than 900, the water pump is automatically off. We set it as a minimum and a maximum value in the Arduino coding. Okay, and also we can operate it manually in our smartphone by on off the water pump. As you now can see, the soil is wet, so the resistance level shown to us is 996. For example, when I put out the pin from the soil, the level of the resistance goes to 1. This is show the sensor detect the dryness in the soil, and when I put it back into the soil, the sensor will detect the wet in water in the soil. This is the exact model of my project. We set up it into a box which we can hold all the components inside of the box. We only place the sensor probe and the water pump only outside the box. Inside the box we place the Arduino relay and the sensor and the power backup battery. On the top of the box we set the 3-volt solar panel, and the outside of the box in the side we place the DC power jack which came out from the battery, and the voltage regulator and the switch to control the circuit on or off. And also we place holes for Arduino to connect the voltage and the setting pin, and the side of the another hole is placed for get out the sensor probe wire and the DC water pump motor wire. My project is basically used for watering the plants, especially for a germination of a seed, and also the plants we basically use in our house, for example the flowering plants. Finally, thanks for watching my video.